Let us solve OpenStax University Physics, Volume 1, Chapter 5, Problem 52. Player A pushes player B backward with a force of 800 newtons. Player B and his equipment have a mass of 90 kilograms, and he accelerates backward at 0.75 meters per second squared. Part A asks for the friction force between player B's feet and the grass. Part B asks what force player A exerts on the ground if player A and his equipment have a mass of 110 kilograms. Those questions refer to different objects, so we will draw a separate free body diagram for each player. Begin by choosing the object whose motion we are analyzing. For part A, that system is player B. In this drawing, backward for player B points to the right, so choose rightward as positive x. The acceleration is then positive. Choosing the opposite direction would also work if every sign changed consistently. Now, isolate player B. Player A pushes him rightward with 800 newtons, while the grass exerts friction leftward on his feet. Weight acts downward, and the normal force from the ground acts upward. The vertical forces balance because player B has no vertical acceleration. They will disappear from the horizontal equation, but showing them keeps the free body diagram complete. Only forces acting on player B belong here. Before writing the equation, test the proposed force diagram. If 800 newtons were the only horizontal force, player B's acceleration would be 8.89 meters per second squared. That is far larger than the given acceleration, so friction from the grass must oppose the push. With rightward positive, Newton's second law gives 800 minus the friction force equals 90 times 0.75. There is one equation and one unknown, so the diagram contains enough information. Solving gives a friction magnitude of 732.5 newtons. It acts forward on player B, opposite the 800 newton backward push. Its smaller magnitude leaves the required backward net force. For part B, change systems and isolate player A. During the push, contact keeps the players moving together horizontally, so player A has the same rightward acceleration, 0.75 meters per second squared. The grass exerts a rightward static friction force on player A. Weight and the normal force again balance vertically, but the horizontal diagram is not complete until we include the contact force from player B. Player A's 800 newton force on player B has a Newton's third law partner. Player B pushes player A with the same magnitude in the opposite direction. Therefore, the missing force on player A is 800 newtons leftward. These two forces do not cancel because they act on different players. Each belongs on a different free body diagram. That object label in the force notation is what keeps the bookkeeping clear. Return to player A's free body diagram and add player B's 800 newton force to the left. Now the diagram is complete. Ground friction points right, player B's contact force points left, and the vertical forces balance. The horizontal equation will come directly from this completed diagram. Apply Newton's second law to player A. The ground's friction force points right, and player B's 800 newton contact force points left. Thus, the ground force minus 800 equals 110 times 0.75. Solving gives 882.5 newtons for the force of the ground on player A. It must exceed 800 newtons so that the remaining net force accelerates player A to the right. Be careful. Our equation found the force of the ground on player A, but the question asks for player A's force on the ground. Those are another Newton's third law pair, so they have equal magnitude and opposite direction. Therefore, player A exerts a force of 882.5 newtons backward on the ground. The ground exerts the same magnitude forward on player A. The requested answer is the first of those two directions. The reusable strategy is to isolate one object, draw every external force on it, choose an axis, and apply Newton's second law. When objects interact, check that each force has an equal and opposite third law partner on the other object. For player B, Grass friction is 732.5 newtons forward. Player A exerts 882.5 newtons backward on the ground. Always finish by checking which object exerts the force and which object receives it.